this Word file. And then there were the individual autocorrelations, even though I call them ACF. Lily, thank you. So these are the individual autocorrelations. And then we tested each one for significance separately. We tested each one for significance. And then we used a joint test, which is what I call the portmanteau test. We tested all of them being equal to 0 at the same time. Okay. So what I'm going to do, I'm going to use a different set of data today. I'll try to generate each of these numbers, each of these autocorrelations using R. And then we're going to test. I don't know if I should test for each one, but yeah, maybe why not? Maybe let's test for each one. But more importantly, I want us to first do the portmanteau test, test the joint. And if you remember, let me stop sharing. Wait, am I recording yet? No, I'm not recording. All right, let me start to record.
This meeting is being recorded.
Okay, so hi everybody. I'm going to repeat what I just said. Today, what I plan to do is do an example that gives us each of these autocorrelations. And then we shall try to repeat what we did last week, doing the box-pierce test, doing the Leon-Box test. But I will try to do it on R. So using R, I'm going to generate these numbers, each of these numbers, okay, for a different data set. And then using R, we're going to do this test. That's what I plan to do. It's 6:02 now. So in your, on Blackboard, I have uploaded the data I want to use today. So you should have access to it. It's called R Practice New Macro Data. So you should have access to it right now. And then, what was the formula we used last week? We used this equation last week. We use the following equation we use this to build confidence interval. And then we used these formulas, box-pierce, and then Leon-Box. So I'm going to calculate the autocorrelations at each lag for 5 lags. And then we are going to test it on R. And then we're going to check our numbers on Excel, okay? The Excel work, I might let you do it. I might give you like 5 minutes of class, 5 or 10 minutes of class for you to replicate, for you to use these equations, these two, to calculate the box-pierce, this one, and the LB, Leon-Box, using this equation. And then you and I will do the chi-squared test. Okay, the chi-squared test. I'll show you how to do that. All right. Okay, you guys ready? Look, again, usually when I want to do R in class, I run into all kinds of crazy problems. So in case I do run into a problem, I shall, before class, I did everything on an R session myself. I spent a few minutes doing it. Luckily, I saved it. So if my session doesn't work now, I'll go call up the one I did, and I'll explain to you line by line so that you can run it through yourself. In 5 minutes from now, did I say 605 or 610? I think either 605 now or at 610, there is a Word file that you will have access to on Blackboard. That Word file contains the commands I'm going to use for what I want to do now. So you can simply call up your RStudio, copy the commands I have in that Word file, place it in your R, and then execute the steps, execute the command steps step by step, as I'm going to do right now. So you can follow me, okay? And I would like everybody to try to follow me. If you make a mistake, that's okay, okay? If I make a mistake, that's okay too. I'll try to fix the mistake. But if it doesn't work for me at all, something about Zoom, when I want to do the R session and I have done it before class, it just doesn't work for me. So let's see. Okay, so everybody, you ready? Okay. Where's my R session? Good. Okay, please tell me you see my RStudio, everybody?
Yes.
Okay. So look, all these commands I have, you have them in the Word file. Does anybody see the Word file on Blackboard?
It's not there yet.
Okay, so in like 4 or 5 minutes, in 3 minutes, it will be there. So it contains all of this. And what, you want me to wait for 3 minutes so you can copy and go along with me? Is it, you want me to do that? I love it when you give the professor the power. Okay, I wanted to, okay, so this, where many of you will run into trouble, these first 2 lines, because these are very specific to me. So I am setting my working directory. This is my folder where I have my R programs. Okay, this one, I call it R_folder. So you have to tell the program where to go, what folder to go to on your computer. So this is the folder. This is the folder where I have all my R programs, everything. And in that folder, this R folder, I have this file, the one you have access to. Sorry, it's a very long name, but there's a reason why I gave it this long name. So look, and by the way, I saved it. You guys, you have access to it now. It's a CSV file. I did not save it as an XLS, Excel file. Okay? If you want to read data from Excel into R, first you have to save it, remove it from .xsl, .xls. You have to, the same Excel file, copy it, save it in a file, but the extension should be CSV, okay? What is CSV again? I forgot. CSV, I remember in a few minutes. Okay, so this is the only extension that R can read an Excel file from and into R. Yes, it's, well, yes. Corpus. Thank you. You know, yes, thank you. You say these acronyms so much, you forget them. Okay, so, so XLS is the Excel extension, or in the newer Excel is XLSX or something like that. So go ahead and save whatever data you want into Excel, read it into Excel with extension .xls, and then copy it into another file, CSV extension, okay? You guys, you know how to do that before you read it into R, okay? Thank you, Chambo. Thank you, Danny. All right. So you have to have your own, whatever you call your own folder. See, look, so my folder is in my C drive under users, Joseph Onochie, my desktop, and on my desktop, I have this R folder, okay? And then I am going to read, and this is the, hello guys, you see that read.csv. That is how you read CSV data into R. So read the, so everything here, how do you say, the parentheses, no, the quotes, read the CSV, open parentheses, open double quotes, C colon / user. These are all specific to me. My desktop, and then my folder, and then the file. And then close double quotes, close parentheses. Okay, so if you guys are ready, please watch me now. If you look at Blackboard, you will see my Word file right now with the commands. It should be there. Somebody tell me it's there. Okay, okay, good. So look, everything else from here, from line 4 here to the end of the program, you don't need to change. But for you, if you want to walk along with me, you need to change the first 2 lines to be very specific to your computer, okay? You can do that now, or you can just watch me. All right. So yes, I know some of you are our geniuses. You tell me I can run all my programs at once. Yes, I can. But I don't want to, because this is a class. I want to do it step by step, okay? And if I drive you crazy, if I'm driving you crazy, I apologize for that. Danny, am I driving you crazy by running it one by one? Where the heck is Danny?
You drove him so crazy that he's silent.
He's the one driving me crazy.
I'm following you, Professor.
Okay, all right. So okay. Danny, my man. Okay, so look, I highlighted the first line, and you see, I want to run it. So I run it. Please, everybody, fingers crossed for more for me. Yeah, it ran. See that? It ran here, down here, okay? You see that, everybody? Okay. Whew, the tension is killing me. The stress is killing me. All right. Hey, William, you look so cool with that sunshade you have on your face. You can sell it to me later. All right, so I'm going to run the second line now. So what have I done? I have told this program where I have all my data and everything. So I'm now telling it to go bring my data into R. Okay, so it worked. You see, it tells me it's done it. All right, now I want to do 2 things. Now I want to install some packages that you and I will use to do this stuff. Now, everybody, please watch me what I'm going to do right now. You see this package? I have to install the zoo package and then bring it into my work. This one, XTS. Your book recommends you install it, but I am going to put the hashtag here in front of these 2 because I am not going to run them, because it turns out that in my R program, my version, once I install the package zoo, it also installs XTS and it also installs TTR. So I am not going to mess with them unless something goes wrong and I have to install them individually. So everybody understands the hashtag I'm putting in front of them, right? What does that mean, the hashtag? It's comment. If I need to run them, I'll go remove the hashtag and run them. But for now, I don't need to. So now let me install the zoo package. Okay, step by step. Sorry, it's driving some of you crazy. All right, so I'm installing the zoo package. All right. It's telling me, I hope it's working. Okay, it's working. So the zoo comes with other things. Okay, so now so like I explained, this is like bringing it into the Excel, but now I want to work with it. So I'm going to say library, bring it into my workspace. All right. Okay. Now I am going to install another program. This program, after using Zoo, I'm going to try to use this second program called Ports. Okay, P-O-R-T-E-S. And I'm going to library it because Ports will also allow me to do the ACF and the portmanteau test, but using a different command, okay? So I'm going to install this now. As you'll see, as we go in this semester, sometimes to do the same test, I may introduce you to 2 or 3 packages because some packages are more user-friendly. Some of them are more powerful. So I'll introduce you to easy ones as well as powerful ones, okay? So let me install Ports, hoping it won't give me any error message. Okay, I think it's working. Come on. All right, I think it's working. You see, it has installed so many things. And if you look here, it says, no, it's don't worry. I'll show you later. Now let me go library it, meaning let me bring it into my workspace so I can now use it. So I'm calling it up. I like this program Ports because in my private work, I use it before I use a big program, I use this one to do forecasting, and I test things out using this program before I do a main program or before I go to another software. I use this simple software. It's strong enough to do many things I want to do, okay? And when we want to do GARCH, when we want to do certain more complicated stuff, we can use this. Okay, so what do I want to do now? Let's back up here. I told the R program to read this data. It's a macroeconomic data and put it in data here. Okay, so everything in this file, in this Excel CSV file, has been stored in data here. Now, what I want to do subsequently is I want to declare data, DATA, as a time series data. So I want to declare data as a time series data and store it in a temporary space data1. Okay, that's the next thing I'm going to do. I hope it works. Okay, so I'm going to run this. Okay, so down here, it tells me that it now recognizes data as a time series data, but I'm giving it a different name. I'm putting it in a different space. So my data is still there, but my data1 now is recognized as a time series. So I am going to print. I'm going to ask it to show me data1. Data1 will be exactly equal to like data, but now the computer, the R recognizes it as a time series data, so it can do time series analysis with it. You see that? So now it has sequenced it, frequency of 1. Okay, so let me back up. So my data has frequency of 1. Okay. Actually, it turns out that this is a quarterly data. Look at the title here, quarters. So this number is quarterly GDP for a particular year. The next quarter, 3 quarters, 4 quarters. So in 1 year, there are 4 quarters, okay? But because I told the R to regard this as a TS data time series, you see it has given it quarter 1, 2, 3, 4, 5, but it says frequency is 1. So it recognizes it as a time series with 1 time period between the two. But you and I know that 1 time period between the two numbers is 1 quarter, is 3 months. All right, so R has sequenced it to be, it will recognize it as time series data. All right, so let me just do a few things. Let me look at the beginning of the data, the start of the data. Oh no, sorry. All right, so I'm going to look at the start of the data. So the start is 1 column, 1 row. All right, let me look at the top, top 5 or top 6? I think it's top 5 or top 6 numbers. I use the command head. So I tell it to give me the head of the data. It gives it's top 6. So it tells me GDP, PDI, PCE, profits, dividends. This is personal disposable income. What is PCE? Private, expenditure, something expenditure. All right. Okay, so, but I am interested in the first column, GDP. That's what we're going to use, all right? Now, so look at this command here. I am telling, guys, look at this command on my line 20. I am telling R to go to the time series and look at every row. You see here, it says go to data 1, capture every row. Remember, every matrix it's in rows and columns. I say get column GDP and bring all the row numbers, all the numbers in the rows for GDP, and put everything in temporary space Y. So if I run this now, I'm going to introduce something new called Y, but Y contains only the GDP data from my database. So it ran, and the next line, I'm telling R to show me Y, okay? It will show me the same database, but only with GDP data. Is everybody following me?
Yes.
Okay, good. If you have questions, please stop me, okay? Start tells me, where does the data, the time series data begin? One and one. Oh, 1 row, 1 column, okay. So now I'm going to ask R to show me my new. So it has come in and extracted only the GDP data, only GDP. Every number you see here is only GDP. If you doubt me, go back to the original database with all the columns and check. Okay, it has 88 GDP numbers. So if you want to check, look, the first one is 2872.8. The second one is 2860.3. Let's go check. 2872, 2860. All right, see GDP 2872.8, 2860.3. So that command simply said, go get the column GDP and put all the rows. I left the row number blank and put a comma. So go to the column GDP and extract all the numbers in the 88 rows. That's what it means. Okay, so my next command now is, so with this, I can do several things, but okay, what is this? This is the command I used already. I have used it, so I don't want to repeat it, okay? Now, let's go and do serial dependence.
Just a quick question on what you just skipped over.
Which one?
Just the x equals data one dot ts.
This one?
Yeah, those two.
Mhm.
What do you mean by it was repetitive? And I was also having a hard time doing it in R. I think because of the .ts.
Say that again.
So we've basically confirmed like what data one is. We've already, but we haven't actually made data one.ts like a time series.
Yes, yes. So okay, all right. You see, so these two commands are the appropriate commands if I was using another package.
Okay. So maybe that wasn't working.
Because you see, I copied these commands from a Word file I have that I have approximately 300 lines of codes. I use them to do some research sometime. So for today's class, I just said, what do I need to do today? So I went to that Word file with about 300 lines of code, and I copied some of them just for this class. Now, in that file with, I say, more than 300 lines of code, I have installed several packages, okay? And so I have installed several packages, and sometimes I don't remember which package does what and what command works with what package. But look, you see, Lily, was that you?
Yep, it was me. It works as long as I delete the .ts, which is probably just
Yes, but
the package that we're using.
Okay, no, yes, but you see here, up here, I have said data one equals TS data.
Yes, we've already.
Then data. So for using the zoo package, these are the correct commands.
Got it. So we don't need to. It's repetitive. Got it.
Yes. So the other one is for another package.
Got it. Thank you so much.
All right. I think the ports package uses this syntax. I think so. All right. So now I'm going to do the ACF. Does anybody remind me what is my Y again? What's in Y? Y is my GDP.
GDP.
Okay. So now I'm going to do Lily, that's your friend, ACF, autocorrelation function. Because I say it's a function, it's going to give me the autocorrelations and the func and the lags. And if you look on the right hand side here, bottom right space, I think it's going to give it to me now. Okay. You see that? Do you see that? You see on the bottom, you see here, right? Do you see this?
Yes.
The bottom right-hand corner, that is the autocorrelation function. Why do I call it a function? Because it's a table or a graph that shows me the autocorrelations on the y-axis and the lags on the x-axis. So here it has measured it up to lag 12. I'm sorry, up to lag what, 20 or something? Are these lags 0 to 95% confidence? Are these lags 0?
No,
Why do you say no?
because they don't fall within the range.
My data is so screwed up. This is macroeconomics data. It typically looks like this. You see, they all fall outside of the range. All of them fall outside of the range. So they are statistically different from 0. So in other words, we shall reject the null hypothesis that each of this is 0 because they fall outside remember the 2 standard deviations bound line. up and down. Okay.
So that means that there is no white noise?
This is definitely not white noise.
Okay.
This is anything but white noise.
So when you reject the null hypothesis, it's no white noise. Okay, thank you.
Yes, because the null hypothesis is that the autocorrelation is equal to 0 at a specific lag. If you reject that, you are saying it's not 0. It's statistically not 0. If it's statistically not 0, it can be negative or it can be positive. Here, we just happen to have all of them positive. This is GDP data. It's all usually messed up. Macroeconomic data is usually messed up like this. Okay. Roxolana, was that you asking me?
Yes.
Okay, awesome.
So is this like are these some tests that we'll have to run on like our actual test where we're gonna have to determine whether there's white noise or not?
Yes.
Okay.
I'm going to do it right now. Okay.
Yes.
So this command ACF of Y simply tells R to calculate the ACF of GDP. Okay. Now let me see if they can give here. Look, in this graph, it just plotted the graph. But let me see if it will give me the numbers for ACF. Let me try. It may not work. Let me in here. Let's do dollar ACF parenthesis Y, because you see, unlike Excel that gives you all your results on the page, whether you want or not, R will calculate it and hold on to the numbers. But if you want the numbers, you have to ask R to give it to you. I'm hoping that for the zoo package, I'm hoping this is the right command. Okay, I don't know. All right, it's not giving me that. Okay, I have it somewhere. Let's just go on. Now, if I want to use the ports, all right, let's not use the port. So let me come in here because I want to use I'm using the zoo. If I were to use the port, PORTS package, this would be the command. But for the zoo package, these are the commands. So I want to say ACF for only 5 lags. Okay.
I have a quick question.
Yes.
We're running multiple packages right now. So as you
No,
mentioned,
no. I'm using only one package now.
we're only using ports.
No, we're only using zoo now.
Oh,
But I installed zoo, I installed ports.
okay. So we installed all of them. So how are you specifying which package to use and which syntax to use?
Because I know. Okay. Okay. No, hold on. I know where you're going. I know the next comment you're going to make.
Okay, thank you.
Right. You're going to say, Professor, what are you drinking or smoking? Okay. Now, everything I have run so far, you see this command here, this one? You see this one here, this one?
Yes.
I am going to comment it out because it belongs to ports. Okay? So you can comment it out and write a comment here like this. This is used with ports. Okay, I just forgot to delete it while I was preparing for your class. It's my fault, okay? You got me, Roxolana?
Yes.
Okay. This PACF, you can comment it out for now. That is the partial autocorrelation function. I haven't discussed it with you in class, so you can comment it out now. You see, me, I don't comment things out because I know what they are, I can just skip over them. But because many of you are new to this, just put this PACF, comment it out, partial autocorrelation function. I will discuss that maybe in 2 weeks from now, okay? Actually, next week. So everything left here, we're using we're using with zoo. All right. So let me go try the ACF again. Let's see. Okay. You see on the bottom right hand side now, it's ACF, but for only 5 lags. You see that? Everybody see that? But this is the command, ACF parenthesis Y, that's GDP, comma, lag equal to 5. So I have specified how many lags I want the ACF, the autocorrelations for. All right. Now I want to put the same, all the ACFs, I want to put them in F1. I use F1 because your textbook uses F1. I could have used Z, or I could have used J, whatever. So I want to put all these, guys, look at this graph on the bottom right-hand side. It just shows me the bars, the lines. It doesn't tell me what the numbers are. I can just approximately read the numbers. I know that the autocorrelation at lag 0 must be equal to what?
1.
Plus or minus?
Plus.
Okay. So this is +1 here. But the other ones are less than +1, but I can just approximate them. But I want to see the actual numbers. So what do? I put them in F1, and I use this syntax, F1 $ACF, okay? Which is what I wanted to try here. It wouldn't work. So maybe I think this syntax is for another, but let me not go there. Okay, so let me do this. Hopefully this works. Where's my run data? Okay. So I'm going to run this program now, that line. Okay, so in other words, I have stored all the results in F1. And now let's see if I can look at F1 to see the actual numbers. So let me run it. Okay, so look at the actual autocorrelation numbers. So at lag 0 is 1.000. At lag 1 is 0.9689. You see they are they are close to +1. At lag, so at lag, the first autocorrelation it gives me is at lag 0. So if I ask it for autocorrelation for 5 lags, it gives me 6 numbers because it's 0, 1, 2, 3, 4, 5. You understand? Okay. So at lag 0 is 1. At lag 1 is 0.9689. At lag 2, 0.9352. At lag 3 is 0.901, blah, blah, blah. So it gives me 6. It gives me 6 autocorrelation numbers. Okay, the first one is lag 0, and then each one to lag 5. So now, okay, I'm going to ask everybody, can you please take a picture of these numbers, because I want you to plug them into Excel and use just in case you cannot replicate this program yourself. The only reason why you cannot get all these commands to work is if you make a mistake in your first 2 lines of code, your working directory and reading in the file, okay? So now I am going to use each of these to test for the autocorrelations to see if they are significant. Just in case we run out of time, let me go and do the the box pierce, and the Leon box. So what I'm going to ask each person to do is use these lags, use these autocorrelations, and by hand in Excel, calculate the Q statistics, calculate the box pairs, calculate the Leon box, and then for each of these lags, do the test for individual ACs, autocorrelation, just like we did last week. Build the confidence interval. Actually, don't bother because the graph already tells us that each one is significantly different from 0, right? Yes? So don't bother to test each one because we know already from this picture. But let's see jointly whether they are jointly 0, all 0 at the same time. Okay, what kind of test am I going to perform now? What did I call it?
Portmanteau.
The portmanteau test. Yes, that's what I'm going to do. All right. So there are 2 types of portmanteau test, box pierce, and then the LB, Leon box. So let's do the first one. Now look at it. Look at the syntax, Roxolana. Look at the syntax for for the zoo box period test parenthesis my data GDP, that's Y, comma, lags, and type. Box test is the same, applicable to both types. But if I want to do box pairs, I specify box type equals box pairs in quotes, double quotes. And if I want to do Leon box, I specify Leon box in double quotes. Now, please see this. All these commands are very case sensitive. So you have to type it exactly the way it appears here. But because I already gave you the command, just go ahead and copy the command in the Word document and plug it in, okay? Thank you, William. Yes, that's the Word document. Thank you.
No problem.
All right, you guys are very nice. I have so many assistant professors in the class. Thank you. So now let's do the box pierce. Not the box, yes, let's do the box pierce, okay? Remember what the box pierce does from last week? We have to calculate the Q statistic, and then remember the Q statistic is distributed like chi-squared. And then with the degrees of freedom, we can, once we calculate the Q, that's the sample Q, then we can convert it to chi-squared, sample chi-squared, and then we can go test it using the critical value of the chi-squared. But that's what I did last week. But R will give you the chi-squared from the sample and then calculate the p-value for you. That's the beauty of R. It calculates the p-value for you, for us, so that we can just look at the p-value. If the p-value is more than 0.05, then we say we do not reject. We quote unquote accept. If our p-value is below 0.05, then we have to reject the null. And what does the null say, Lily? The null says that the ACF is equal to 0. Okay? Okay, so let me run this now. So see here, so the box pairs for GDP, the box pairs, the chi-squared, the x squared, chi-squared, the sample chi-squared is 357.64, degrees of freedom equal to 5, number of lags. Look here, look at the p-value. P-value is less than, does anybody know what this number means? 2.2 times exponent negative 16. Does anybody know what that number means?
2.2 to the power of negative 16.
So it's 2.2 to the power of 2.2 to the power of 10 to the power of negative 16, right?
2.2 times 10 to the power of negative 16,
So
you're saying, Professor?
yes, it's 2.2 times 10 to the negative 16. In other words, it's 2.2 divided by 1 and 16 zeros. So is that close to 0 or what? So again, guys, do I accept the null or do I reject the null that says that ACFs, all the ACFs together are equal to 0? Do I accept the null or do I reject the null?
Accept.
You accept. You accept, right?
Do not reject.
Yeah.
Remember, for p-value, if your p-value is below alpha of 0.05,
You reject.
you reject. Is this number less than 0.05?
Yeah, it is. So you reject.
It is way less than 0.05. So we reject what?
The hypothesis that
reject the
all
null.
of them are
Which
0.
hypothesis? Hold on, which hypothesis? The null or the alternative? Remember there are
The
two.
null.
Oh,
So we reject the null. But what does the null say that you are rejecting?
that ACF is equal to 0
At what lag?
at all lags.
At each of those lags together. It's a
Correct.
joint test. So
At
the
least
null-
one of them is not 0, basically.
So at least one of them is not 0. Fantastic. That's the alternative. You see that? So what I would like for you guys to do is to use each of these numbers and go to Excel and repeat the exercise I did last week. Okay, now let me just finish up and do the Leon box. Okay. You see, the first one is the box pierce. The second one is the Leon box, or box Leon, they call it. Look, the same thing. Practically the same thing. The chi-squared is different in this case. This is 357.64, and this is 378.1. Because those two tests are different the way we calculate them. Do you guys understand this? Yes? Uh-oh, you're giving me the silent treatment, guys. Why? Okay, everybody following?
Yes, so if we had to solve a problem like this on a test, we can just use R, right? We don't really have to use Excel. You just want us to do Excel for our own practice, right?
Yes, but in the exam, I can run this, show you the ACF at each lag, and ask you to calculate by hand the chi-squared, the Q statistic, and then check the chi-squared critical value. I can ask you to do that. I'll show you how to check the critical value in a second.
Okay, I also have a question. So where it shows like the ACF, it says 1, 2, 3, 4, 5, 6. Does that start from 0 or does it start from 1? Because I thought it was lag 0.
Okay, in case you forget, what is the autocorrelation at lag 0?
It's 1.
Okay, so this must be at lag 0, right?
Yes. Okay.
And then this is lag 1, lag 2, lag 3, lag 4, lag 5. Okay, because look, if you see here, we have 6 lags. We have lag 0 plus 5 other lags, so that's why. All right.
Okay, so when we calculate it on Excel, when we have to do the individual test, there's a T there. So would we use all of the observations or would we only write T as 5?
No, you will use all the observations.
Okay. Thank you.
So how many observations are here? I think there are 88. Right? For
Right.
GDP, yeah, let's go. Let's check
I
it. Look,
think so.
that is it. That's the GDP. It begins 1. So from 1 up to 88.
Yep.
So your T will be 88. So I like everybody, again, these are all exam questions. I can just run R, 5 lags, give you the autocorrelation function, give you this is what we call the autocorrelation function. Where's my friend Lily? This one, these numbers is the autocorrelation function. I have the graph is the ACF because it's visual, but I don't need to plot the graph. This is also a function, but in table form. So I can run this on R and simply give you the R output and ask you to use these numbers to verify whether you accept the null, whether you reject the null or you do not reject the null. Okay? Who was
In
asking?
Excel, we'd only be doing the first 5 lags though, correct? We're not doing it for all of them, or maybe I'm misunderstanding.
No, you will do it for as many lags as the professor asks you to do.
Oh, okay. You got it. You got it.
Who is the boss here? It's me, at least up until 7:05. After that, you guys can boss me around. But okay, you understand? Okay. Where's my buddy Lily?
I'm here.
Okay, and Roxalana. I'm going to do the same thing, but using ports, the package ports. Because for ports, where's the command for ports? Let's see, let me show you the command for ports. So maybe you want to write it down. No. Oh, I erased it, okay. Let's see. Okay, so for ports, this is the command for ports, box pierce Y. You see that? Oh, actually, I added the command, use the ports package for this test. And then the Leon box Y, this is used with ports, okay? So now let me remove this comment here in front. Oops. So let me run this program now. Let me run this. If you use only zoo, this command will not work. This command should work because I also installed and library brought it in ports. Fingers crossed, let me see if it works. Okay, see, you see? It works here. Box pierce Y, it works here because this is the syntax. This is how you type the command with ports. Remember how I typed the command with zoo, box, period, test, parenthesis, Y, comma, what else? Y, comma, what was in the middle?
Lag
Lag equal to whatever lag,
and type.
and then type equal to double quotes. So that is we call it the syntax. That's how you write the sentence for the command using zoo. But for ports, you simply type box, pierce, and look at the way you type box. Uppercase B, lowercase ox, uppercase P. This drives me crazy when I'm in a hurry planning for class and I'm making some stupid mistakes, usually because I'm just typing in a hurry, okay? So if you make a mistake, don't freak out. Check your case sensitivity. All right, so here, see what it gives me. It gives me the chi-squared at like 5, like 10, like 15, like 20, like 25, like 30. So if I want only the first 5 lags, I have to go to the literature and look up how to express the command for port to give me like 0, like 1, like 2, like 3, like 4, like 5. I don't have it here. I have to go back to my file and check. But you guys can check. Just Google it, okay? Google the package ports. It will give you all the commands, the appropriate commands, and you can choose. Okay, so this is box pierce. Now let's compare this box pierce with ports to the box pierce with zoo. So this is with zoo. Let me go back up. Sorry. With zoo, my box pierce was 357.64 at lag 5. With ports, at lag 5 is 357.6434. You see that? You see that, guys? Silence.
Yes.
Okay. Are you surprised it's the same number?
No,
Why not?
it's the same formula they
It's
use.
exactly the same formula we use. Thank you. Okay, so let me go on. Look at the syntax for Leon box. LJUNG BOX, one word. The L is uppercase, the B is uppercase. Okay. So let me run it. If you are new to R, okay? If you are new to R, you see how I type the command and I put the comment next to the command. It will run. But if I put this hashtag in front of the B, then it will regard the whole line as comment, and I cannot run it. But if you, as long as the hashtag is not in before the command, it will run it. Okay. So whenever I do complicated programming, I usually type the command, and right next to it, I use hashtag to describe what I have done, just in case I come back 6 months later to redo the same empirical work for my research. I don't need to say, oh, why did I use this command, or what does this command do? So here, look, I said box pierce Y, use the ports package for this test. So I know that to use this command, I have to go install the ports and then library it in. Okay, so let me run this one, the Leon box. So here, the Leon box runs. And you see in the result, it also tells me this is used with the ports. At lag 5, it's 378.1002. And the p-value is really essentially 0. So you reject the null. Let me go back and check the box. Look at it up here. I don't need to go back. So with the zoo package, this Leon box is 378.1. With the ports package is 378.1. Okay. So if you calculate the Q statistic using using Excel yourself with the formulas I gave you last week, you should get exactly these two numbers. 378.1 at lag 5 for the Leon box, and then 357.64 for 5 lags using the box pierce. Okay, guys, any questions? Yes, no?
Nope, got it.
Okay. Homework between now and Thursday, please let me show you. Okay, so if there are no questions, I am going to save this file so that I don't lose it. So I want to save it in my R folder. I want to save it as, somebody give me a name. Huh? favorite class echo 40. I'm joking. All right. Class exercise, class practice March. What's today? March 2 or March 3? March 2, 2021. Okay, so I save it in my R folder. All right. And then so I can now exit my, let me not do anything. Let me not do anything silly in case I need to come back. So I'll stop sharing. So guys, let me give you something to do between now and Thursday. Let's go to the textbook. Oh no, you're not seeing this now. So let me share. Where's my textbook? Sorry, I can't seem to find my textbook. Just bear with me, I'll look for it now. But I thought I had my textbook here. Anyway, look, let me, okay, it's okay. I have my textbook actually. Let me bring it in. It's just not showing here. Okay. Gosh, what's the matter? What am I doing wrong here? You guys cannot see my, oh, here it is. Oh goodness, all I had to do was scroll down. Sorry about that. Okay, so if you go to your textbook, page 45, 46, and 47, you will see this little packet, this little exercises. Please, I want everybody here to do those exercises, the R programs. So let me back up. Let me back up to page 45. Let's go to page 45. So page 45 begins the autocorrelation function, and then it describes it, all the math here. You already know what this math says, so don't. And then on page 46, it gives you this program. Please repeat this program, everybody. You need to download the data. It tells you how and exactly which data to use. You probably have downloaded the data from chapter 1 using quant mod. Okay, so don't forget, everybody, before you download data, you need quant mod, QUANT-MOD, that's the package. So on page 45 and 46, it tells you exactly which data it's using, so you can download the data and then plug in all these commands, make sure you get exactly the same result and the same graph. And then it will test for individuals. So remember here, this is page 46. It says test. So do this program, and then it says testing individual ACFs. It continues onto page 47. Page 47, it shows you how to test. In this case, it uses the t-test, TT. Okay? So this is the command. You just do TT equals that times square root of how many observations you have, 516. Okay, so TT equals the lag at lag 12 here. So it's 13, line 13 here, times square root of the number of observations. Look, it explains everything here for you. This is similar to what we did last week, but similar to, remember last class, I built the confidence interval, the dashed line above, the dashed line below, such that when you plot the ACFs, if they are not significantly different from 0, if they are really statistically 0, then the lags will fall between those two dashed lines. Okay, so do this exercise on R, and then one final one on page, the portmanteau test. Okay. Did they do the portmanteau test here? Yes, I think they did. I think that's on page, yeah, page 49, I think. Yeah, that's it. Excuse me, guys. So look at it here. So the box test, this is the, so in your book, it's using box test for IBM, for the returns to IBM. And then below here, the box test for the natural log of IBM. You see that? So this is IBM. This is natural log of IBM. So I'd like each of you to please repeat these three programs on page 45, 46, 47, 48, 49. There are 3 R programs. So practice them between now and Tuesday and Thursday, and then we shall do something else on Thursday, okay? All right, I'm going to stop recording now.
The recording has stopped.
All right. Everybody okay?
Professor, do you have a particular date in mind for our midterm? It's
So somebody was asking me that the other day. I don't for now, because I want to, the midterm will not be at least for 2 weeks, because I want to complete something, and it will take me at least 2 weeks to complete it. When do you guys want the midterm? When do you have midterms? You have midterms now at Baruch?
my first next week. Next Wednesday is my first midterm. That's why I was asking. Because
Okay, no, I won't, midterms will not be within the next 2 weeks at all. But we can, will you give me to the next class so I can come up with this 1 or 2 dates and we can all choose?
Yeah, no problem. That's fine.
Okay. All right. Any questions from anybody? No? All right. Bye, guys.
Thank you, Professor.
So I'll see you on Thursday, okay?
Have a great night.
Yeah,
Thank you.
I hope tonight was mildly useful to some of you. All right. See you. Bye, Ian.
Thanks, Professor. Have a good night.
Bye, Peter. Bye, Dimitri.
Professor,
Yep.
for those